right, so on number 1, looking at my domain restrictions, and this is an example where they did not use a comma, but there's still a clear separation between the function rule that's been given and the domain restriction. There's not a comma, but there is this word if. Everything after the ifs are our domain restrictions. So looking at the numbers in here, I see that we're going to have fences at -6 and 3. So the first thing I'm going to do is get my guidelines for that drawn in. -6. And +3. This top function is to the left of -6. This is f of x equals 8. So it is a constant function. It's going to look like a horizontal line up here at 8. So coming over like this, when it hits the fence, it is a filled in dot because it has that or equal to with our -6 there. X is less than or equal to -6. In the middle, we have an absolute value function. F of x equals the absolute value of x plus 1 minus 7. So this is going to look just like the absolute value parent function, except it has been shifted to the left 1 and down 7. Do you need another copy of this, dear? Not a problem at all. There you are. So going to the left 1 and down 7 would put me right here for the vertex of this absolute value. There are no stretches or compressions compared to the parent because we don't have an a value out in front here. So from that vertex moving to the right, it has a slope of 1 until we hit the fence. It's going to have a filled in dot over there because, again, over here, x is less than or equal to 3. On the left-hand side of that dot, we have a slope of -1, and it's going to be an open circle where we hit the fence on the left-hand side because we do not have the or equal to there. And then last but not least, we have a square root function that's going to be on the far right. F of x equals negative square root of x minus 3 minus 2. So compared to the parent, this has been shifted right 3, down 2, and reflected over the x-axis. So it has a vertex of 3, -2. Let me scoot this over just a smidge. Yes, sir. Absolutely. There you are. Welcome, ma'am. Sorry. All right, so I'm going to go and put the vertex down first at 3, -2. It's going to be an open circle. It is right on my fence. And we do not have the or equal to with that one. So So an open circle just above where the absolute value ends. Now, normally with a square root function, I'd be looking at something shaped like this. But because it's been reflected over the x-axis, ours is going to scoop down this direction. Parent function, remember, it's the square root of our x values. So if I were to substitute 4 into this function, I would have 4 minus 3. That would give me a 1 underneath my radical. So I'd have negative 1 minus 2. It's going to come down here to negative 3. I probably don't want to use 5 as an input value. 5 minus 3 is going to give me a 2 under the square root. I don't know what the square root of 2 is as a whole number. What is a number that I could put in for x that I would know the square root of? Yes? 7. 7 minus 3 gives me 4, and I do know the square root of 4. So I'm going to come over here. I'm going to be on this line here. I'm going to go ahead and put the point down. 7 minus 3, I'd have 4 under the square root. That would give me negative 2 minus 2, so I'd be down at negative 4. That is probably all I have room to fit on this graph, given that my x-axis only goes out to 11. What would have, if I had some more space, what would have been another good x value to substitute in, Aiden? 12. Because 12 minus 3 is 9, and then I can evaluate that. I get some whole numbers. I had a really good question the other day. I think it was in second period. They said, so we just don't find the other, square roots and plot those points. You are plotting those points when you connect the points that you have plotted. When you connect those pieces, you're showing the infinite number of points that are in between there. We're just not trying to find their exact location because they're not whole numbers, so it's very difficult for us to plot those particular pieces. All right, this question didn't ask for it, but I'm going to go ahead and list them off. Our discontinuities. Where do we have discontinuities? Yes, sir.
We have 2 jump discontinuities.
Yes. We have 2 jump discontinuities at what x values?
Negative 6 and positive 3.
-6 and +3. Our domain, hold on, let me see if I can fix this real quick. There we go. Get that thing out of the middle. Domain, this is all the possible x values. I see I've got an arrow going off to the left, so I know I can get any kind of negative x value that runs off my graph. It looks like -6 might be a problem, but I do have a filled in dot there. So there is an x value to evaluate at -6. I can continue getting all the x values in between -6 and 3 on this absolute value function. We do have a filled in dot over here on this fence. And then on the other side, we have another continuous function. So our domain here would be what? Negative infinity to positive infinity, all real numbers. We are defined for all values of x. For my range, we are not defined for all values of the range. I'm going bottom to top because we always start smallest to greatest when we write our interval notation. So what is the lowest this graph ever goes? Negative, not negative. Oh yeah, actually on this side we would get negative infinity. It's traveling very slowly, but it is going down forever. So negative infinity up until we do have a gap here. So this one's going to go down forever. What's the highest we get in this segment of the graph? -2. Open or closed? Like, do I do a parenthesis or a bracket here? Parenthesis. The 2 places where I have an output of -2, I don't actually get to that output of -2. It's -2.000001, but I can't actually arrive at -2. Union, what? 8. It doesn't get any higher or lower than 8. The y values all stay constant at 8, so this goes inside those curly brackets. So when I look at this one, it doesn't go up, it doesn't go down, just stays right there at 8 as the output. Do you guys have any questions for me on this guy? All right. Let's go and look at the second one. This is the other piecewise example that is on your review. And just like I did on number 1, we're going to talk about the discontinuities as well. How many fences are we going to have? 2. We have 3 functions, but when I look at the part that's in the inequality, the part that comes after the if, sometimes they just leave a big space, sometimes there's a comma, but the part at the end is telling me which part of the domain I will follow that particular function rule. I only have 2 numbers in there. I have -2 and +3. So -2. And +3, put these in here. And as long as you leave them dashed when you draw them on the test, I understand that you're not saying these are vertical lines as part of your piecewise. I understand that you are using those as domain restrictions. All right, we have what kind of a shape to the left? Parabola. How do we know that it's a parabola? Just curious. Squared is the highest power we have on any variable. Granted, the variable is inside parentheses, but we would get an x squared if we expanded that. All right, so I have f of x equals -x plus 4 squared minus 2. Where is the vertex for this parabola? -4, -2. So I'm going to go ahead and plot that at -4, -2, right here. Do we have an a value at all? -1. So this has been reflected over the x-axis. Other than that, it looks exactly like the parent. There has been no stretching or compressing. It has just been reflected upside down. So on either side of the vertex, I move left and right 1 and down 1. On either side of the vertex, when I move out 2 to the left and to the right, how far down will I go? 4. So to the left and to the right, I'm going 1, 2, and then down 1, 2, 3, 4, and put my point right here. And I know that parabolas are symmetric, so I'm going to have a corresponding point over here, and I just need to know, is it filled in or open? Are we filled in or open where we hit the fence there? Open, because we do not have the or equal to there. If you are concerned on the test about whether or not you are putting points in the correct location, you are more than welcome to make a table off to the side and substitute in values. What kind of a shape do we have in between these 2 fences? What's going on here? It is a straight line. I have f of x equals -2x plus 3. So this has a y-intercept of 3 and a slope of -2. So I'm going to go to 3 on the y-axis right here, slope of -2. When when I hit the fence at 3, it is an open circle. But when I go backwards and I hit the fence at -2, it is a closed dot, because at -2 we had the or equal to, but at +3 we did not. So then I would grab a straight edge to trace between these. I will make sure that you guys have access to straight edges when you take the test on Monday. I'll also make colored pencils available, because sometimes that makes it easier to keep these things separated. You are by no means required to use these, but if you would like to use these different tools, you are more than welcome to. And then what type of function do we have on the far right? This is a step function. And it has been shifted down 4 from the parent. So I'm going to have to take that into account as I'm graphing this. We're going to have a filled in dot on the fence. So I have that or equal to. Remember, step functions, we are filled in on the left and open on the right, unless it has been reflected in some way from the parent. So filled in on the left and open on the right. If I take 3 and I substitute it in here, would I have to do any rounding for that? Nope. Whole numbers, I leave it as is. For any number that has a decimal, do I round up or down?
Down.
Round down, just like with your age. I know it sounds strange because we call it a greatest integer function. Think of it like your age. Once you've passed that birthday, you still only give the whole number age that you have achieved. All right, so I put 3 in here. 3 minus 4 would be what? -1. So my first step is down here at -1. Then I have 4 minus 4. That would give me 0. So my next step is 1 up. All of my other steps are going to follow from there. Filled in and then open. Take your graphs all the way to the edge of the page, or the edge of your graph. Let's go ahead and talk discontinuities for a moment. Do we have any? Yes. What type of discontinuities do we have? We have jump discontinuity. We actually have more than 2 because my step function, every single x value, I have a jump. Yes, so I have jump discontinuities at x equals, what's the one farthest to the left? -2. And so I would say -2, and because the other side, those jump discontinuities are coming every single integer. I have discontinuities at 3, 4, 5, 6, 7. So I would start listing those out. 3, 4, 5, 6. As soon as you have established a pattern, then we can indicate that that pattern just goes on forever and ever and ever. The other thing that you could say, if you didn't want to list out those values, you could say, and every integer 3 and larger, or all integers greater than or equal to 3. That would be another way that you could state that. Domain. What is our domain? What are the possible x values? Yes, sir.
Negative infinity to all real numbers.
Negative infinity to positive infinity. That is the idea that is encompassed in all real numbers. Yes, you're correct. So over here on the left, we would continue moving into those negative x values forever. We are defined right here at -2. We have every x value in between -2 and 3, and even though it looks funny and I don't have an arrow, this pattern would continue forever and ever and ever. So we will hit every single x value. Even though it is not defined here, for x is 4, it is defined here. What about our range? Negative infinity, I absolutely agree with. That would be coming from over here. I see I can get up to here, up to -2 on this parabola. If I track it over now, the line has a value at -2, and it continues up to here, which would be what, 7? Is there any value for x that you could substitute in and get an output of, say, 8.25? No. I can get up to 7, no problems. After that, the step function is going to take over, and I would have only whole number outputs. So I could get 7, I can get 8, I can get 9, I can get 10. I can't get 7.25 or 8.63. So I have to find another way of stating that. So from negative infinity to 7, there are continuous outputs. After that, it is whole numbers only. So 8, 9, 10, and so forth. But again, only integer values after 7. Scott, does that make sense? Why? Okay. Watch out for your step functions. If it is continuous, that's when we can go negative infinity to positive infinity. If it is discontinuous, which a step function is discontinuous, then we definitely have to watch out for our range values. There was one thing briefly, and it shouldn't be a big deal, but I don't want it to throw anybody off while you're studying. On question number 16, there is a tiny, or sorry, hold on. Is it 16? Interesting. Looks like I fixed it on here. Maybe not. I don't know. Let me look. Yeah, 16. This second function right here. There should be a g in front of that x in our function notation, so that should be g of x. That was just a typo on my part. I've got some copies of it where it's there and some where it's not, so obviously I accidentally hit backspace at some point. But I don't want anybody to get confused about what they're supposed to do on that particular problem. Yes, ma'am?
This is just like to clarify. So when you're like doing that equation, you
Mhm.
multiply first, then you put the symbol in?
So yes and no. We're not multiplying here. We're using composition of functions, but then yes. We're going to do the composition of those two functions first, and then we will substitute the 2 in. So for example, let's go ahead and do part A since we're right here. My outside function is the function f. So the first thing I'm going to find is f of g of x. So I would have negative, anywhere I see an x, we're going to make a substitution. So negative something squared minus something plus 6. Into those places where I've left space, where x was here, that's where I'm going to take my entire function g and substitute it in. So 9x minus 4 would go here and here. Would expand this function. When I square 9x minus 4, I get 81x squared. 9 times 4 is 36, and then I have to double that, so negative 72x plus 16 minus, I'm going to leave this for right now and do all of my distribution at the same time, plus 6. I distribute this negative to everybody, and I distribute this negative. So I would have negative 81x squared plus 72x minus 16 minus 9x plus 4 plus 6. Combine my like terms together. Let's see, 72 minus 9, what's 63? Plus 63x. I have negative 16 and a positive 10, so minus 6. At this point, I would substitute the 2 in now for the x and evaluate it. Always make sure, always make sure before you do any substitutions that 2 would be a valid input into your function g of x, because this is what you're funneling it into first. Is 2 okay as an input value, as a domain value? Yes. Is there any kind of output that we could get from this that would be invalid as input over here? No. Domain for this function is all real numbers. So any kind of number that I would get out of g of x is okay to use as input in f of x. All right, so f of g of 2. I've got negative 81, 2 squared, plus 63 times 2, minus 6. So negative 81 times 4. What is negative 81 times 4? Negative 324 plus 126 minus 6. 204, negative 204. Yes, yes, sir.
For compositions like B, will it also be like f of g of something, would like f of f times g of like x?
Is it possible to do a composition like what you just described? Yes. Am I going to do that to you on the test? No. Yes, ma'am.
This is like for the class topic, but when you like expand the 9 is minus 4, that plus 16 is because of like the opposite, like the SOAP and stuff.
So SOAP is when we're doing a sum and difference of cubes. So what I'm doing here, this plus 16 came from negative 4 times negative 4. So if I think about expanding that binomial, I would have 9x times another 9x. That's how I got that. I would have 9x times negative 4, but then negative 4 times 9x. So that's why I double that middle term. And then negative 4 times negative 4. Yes, sir?
Can we just substitute the 2 in after we just do the f of g of x at the beginning?
Can you substitute the 2 in from the beginning?
Yeah.
Yes, you can. Yes, you can. So you could have substituted the 2 in right here, 9 times 2 minus 4, then square it, then make it negative. 9 times 2 minus 4, distribute the negative to that, plus 6. That would absolutely be valid if I'm asking you to evaluate it for a specific value. Yes. What else would you guys like to see or go over? Yes, ma'am. Number 19, absolutely. Growth of a blue whale. Newborn blue whales are approximately 24 feet long and weigh 3 tons. Seems like cute information, which it is, but they're also telling me specific points. If this is a newborn, what am I telling you in this situation? Yes, ma'am.
That's the least.
That's the least. This is our y-intercept, our initial amounts on these things if they are newborns. So even though we haven't gotten there, our time equals 0 if we're talking about a newborn. We have length and weight for the same time. Young whales are nursed for 7 months and by the time of weaning, they are often 53 feet long and weigh 23 tons. We're going to let L and W denote the length in feet and the weight in tons, respectively, of a whale that is T months of age. So T is our input variable. So this is our independent variable, our X. If L and T are linearly related, express L in terms of T. Linearly related, I know I'm going over a y equals mx plus b equation here. Express L in terms of T. That means this is like my y. If I'm expressing it in terms of T, then T is going to be my X value here, my input, my independent variable. All right, so some things that I know about this situation. I know I'm going to write an L equals equation. I'm going to need the slope, and I'm going to need the y-intercept. Which pieces do I have? Yes, sir. We have our y-intercept, yes. So I'm going to leave a space right now, something t plus what? What is the y-intercept for length? 24. We're going to need to find our slope. So some things that I know about these blue whales. 0, 24 is an ordered pair here. Initial time and the initial length. What else do I know that I could write as a point so that I can find the slope, Aiden?
Would it be 753?
7 and 53. They tell us that they are nursed for 7 months. Remember, T is being measured in months, so that is not going to be a problem for me at all. So 7 for my X value and 53 feet long. So now I can find my slope. Change in y over change in x. How much did my y values change by? Let's see, 53 minus 24, 29 over 7, because I would have 7 minus 0. Can I reduce 29 over 7 at all?
No.
Then I'm just going to leave it like that. 29 over 7. That would be my answer for part A. What is the daily increase in length of a young whale? And we're going to use that 1 month is 30 days. I know not every month is 30 days, but on average, especially when you take February into account, we get approximately 30 days per month. How in the world will I do this? We're going to convert. We know the monthly increase. That's my slope. We have the starting amount, and then the slope indicates the change from month to month. 29 over 7. What is the 29 in this case? Remember, it's change in y over change in x. What is the 29? Not weight, but close. Yes, that's our length. And the 7 is months. We want to use this conversion right here. 1 month is 30 days. So I'm going to take 29 over 7. And I'm going to multiply that. And I'm going to use 1 over 30. Why 1 over 30 and not 30 over 1? How did I decide that that was the right way to set it up?
Days are smaller than months.
I like it.
The number should get
Yes. Yep. So we said we had months in our denominator here. 1 month is equivalent to 30 days. I can cross-cancel units just like I can reduce things by cross-canceling. So I'm going to cross-cancel my units there, and then I can see that days would have to be on the bottom. If I flipped it around the other way, my months would not cancel out. I would end up with 29 times 30 days over months times months. That doesn't make any sense. So we multiply these together. I get 29 over what? 210. What kind of units would we have with that? So we're talking about length. How are we measuring the length? In feet. So this is going to be 29 over 210 feet per day. Part C and D are exactly the same as A and B. The only difference being now we're shifting our attention to the weight instead of to the length. Do you guys want to go through this one, or do you want me to leave this one for you to do now that we have a model in A and B? Again, C and D are exactly like A and B. I'm happy to go through it, or I'm happy to leave this for you guys to go through on your own and use parts A and B as a guide. What is our preference here? Do it on your own? Okay. What else would you guys like to see? Got about 5 more minutes until the bell for the announcements goes off. So I probably have time to do 1 more problem, possibly 2 if it's fast. Good question. All right, so let's go back and look just about notation then. Eni, did you have your hand up for a question? Okay. Number 13 is very similar to 16, except we're not going to substitute anything in for x. So we would do f of g of x. So I would do it just like the first part of number 16, the way I worked that out, where I do the composition first, and then we would need to find the domain. Are there any problems with things that could be inputs for f of x? No. Are there any problems with things that could be inputs for g of x? Can't be negative. Our radical can't be negative. So what values of x would make it a negative under the radical?
Anything less than 7.
Anything less than 7. So if I were going to try to use any values for x here, I have to make sure that all of them are larger than 7, or else I'm not allowed to use them as inputs here. So my domain would be bracket 7 to infinity, since there are no restrictions on my outside function. Amy, which one did you want to see? Number 9, absolutely. There we go. We're going to find the difference quotient. I probably only have time for one of them. Would you guys rather see A or B?
B.
B. Sounds good. All right, so the first thing I'm going to do is into this function, I'm substituting x plus h anywhere I see an x. So I would have x plus h squared minus 5 times x plus h plus 4. That's just that first piece. Minus, coming from this right here, And then I'm going to put parentheses around it so that I don't forget to distribute that negative. And what I put back here is just my function f of x. So exactly as I see it here, I'm going to recopy this after my subtraction sign. X squared minus 5x plus 4. All over h. So I'm going to square my first binomial, x plus h, so I have x squared plus 2xh plus h squared minus 5x minus 5h plus 4. I distribute the negative to everything inside the parentheses, so minus x squared plus 5h minus 4 all over h. I want to try to clean up that numerator. When we have a difference function, we're always going to have pieces that cancel. Give me some things that'll cancel here. X squareds will cancel. 5x will cancel. And the 4s will cancel. Let's write down what we got left. 2xh plus h squared minus 5h all over h. What do you notice about every single piece in our numerator?
You go factor out the factor.
Yes, let's factor out an h. So I would have 2x plus h minus 5 all over h. So my h's are going to cancel here. 2x plus h minus 5 would be my fully simplified expression there. Very quickly before I pop on the announcements, like I said at the beginning of class, I will be posting this video and second period's video. I can't promise there won't be any crossover with questions, but usually people ask for different questions overall. And I have posted all of the answers as well as my solutions on our Canvas page for today. So you have to go to modules and go to today. Here are all of the answers. If you do not know how to get these answers or you didn't get the same thing, complete worked out solutions is at the bottom here in PDF form, showing all of my work and commentary. So there's our first problem, there's the second problem, and so forth. All right?